Hello and welcome to the next training module on the Leviton Security and Automation system. On this training module we're going to cover the topic of energy management. This statistic shows that typical household bulk of energy usage for most residences is for heating and cooling. This is a US statistic, and the US probably do a bit more cooling than we do, but we probably do more heating, so generally speaking it's probably a relatively accurate statistic for the UK market. Even if it's only 50% of your heating costs, your energy costs, then it's worth putting some focus on that in order to try and save energy. Using some sort of intelligent thermostatic system and zoning the system up can really improve efficiency and actually save your customers money, especially in commercial environments where larger buildings, warehouses, office space are going to use more energy, and often offices and warehouses are not as well insulated as residential properties, and a lot of heat's just being lost. So there's some real money savings to be made by having proper energy management in the building. With the Leviton system, we can pretty well cover any type of heating solution, from underfloor heating, radiators, air conditioning, and regardless of the type of heat source, be it a traditional gas or oil boiler or air source or ground source heat pumps. So it's very flexible, not come across a situation yet that we're not able to cope with. And what's also very nice is we have a really good solution both for new build and for retrofit, where you can actually fit this in existing properties without the need to run lots of cables and replumb the place. So we're going to go through a couple of different scenarios here. First of all, we're going to look at underfloor heating, which is the most common for any sort of new build or extension, or you may find some projects have got a combination of where maybe a large extension is being put in and underfloor heating is used in the new bits, and you've got radiators in the old bits, and obviously you can mix and match these different scenarios as required. And if you do that, you still present the user with a common user interface from the various either from the smartphone app or the touchscreen, regardless of what technology is being used to heat that zone. It gives the user a common look and feel, which is nice. So focusing on underfloor heating, typically we'd use this RC1000, which is this device here. It really is a complete energy management module, including a thermostat and timer clock. Typically that's located within the manifold cupboard, adjacent to the manifold, and can control the manifold actuators directly. There is a 24 volt AC output on the back of this unit, and if you stick with 24 volt AC heads on the manifold, you can wire it directly. All manifold manufacturers offer 24 volt AC or 240 volt AC heads on the manifold. Most UK plumbers will naturally go towards a 240 volt heads or actuators, so you need to get in there early and make sure the underfloor heating company use 24 volt AC to make your life as easy as possible. If you have got 240 volt heads, it's not a big deal. They are extremely inexpensive items. Just to whip the 240 volt ones off and replace them with the 24 volt ones is easy to do. It doesn't require draining down the system. They are external to the water containment. They just literally unscrew. Really easy to do. If you really want to stick with the 240 volt ones, then you can use a 24 volt AC to 240 volt relay. But that seems like a lot of extra overhead, and it's just easier just to change the actuators on the manifold to be 24 volt. Now obviously that's located in the manifold cupboard, and you want an accurate temperature measurement within the room that's being controlled. So that's where this little guy here is really useful. This is a remote temperature sensor. It's quite unique because it is flush mount. You can mount it in the wall, and you can actually even skim over it. to make it totally invisible. So it really is a way to win friends with the interior designer for the property, because they love the idea of not having any visible thermostat stuck on the wall. So it's very, very minimalist. So you want one of these remote temperature sensors for each, buried in the wall for each zone, and obviously one of these RC1000s for each zone located in the manifold cupboard, and they wire back. You wire the temperature sensor back to the RC1000. We do require you use shielded Cat5 for that connection. It's a very low, very, very small voltage signal. It's a passive device, this device here, and don't worry, they don't go wrong, they last forever. There's no active electronics inside them. It's a very, very small voltage, so we recommend shielded Cat5 connection just to block out any noise that you may pick up from electrical cables on its way back to the RC1000. And then, of course, individual room control can be gained from the touchscreen or the smartphone app. Or if you do want a temperature display in room, then we have got this temperature display faceplate available in a number of finishes, and this can show you the current temperature, and you can adjust the heat set points and change modes and that sort of stuff on the RC1000. And again, that wires with Cat5 back to the main RC1000. Looking at wiring here, so here you can see this is my sort of underfloor heating manifold down here, and I've got, it's obviously a 4-zone manifold, so there's 4 actuators, and you mount the RC1000s above the manifold and wire directly off the back of the RC1000 onto the actuator to be able to open it and close it. Obviously each RC1000 has current temperature and a heat set point, and obviously when the current temperature goes below the heat set point, it applies 24 volt AC and the actuator opens and allows hot water to flow in the underfloor heating. And when the current temperature reaches the heat set point, then it closes the actuator and stops the hot water flowing under the floor. So that's fairly straightforward, one of those for each zone. And the RC1000's cable back to the Omni controller. It's actually on a bus network, so one Cat5 from the controller to the first RC1000, and then you can daisy chain them, or they can all star wire back and they all go to the same terminals. But when they're all in a row like this, it's simple just to run one Cat5 to the first one and then daisy chain them across. Obviously, if you've got multiple manifolds, say one on each floor, then just run a Cat5 to each manifold cupboard. Obviously, we do also need to control the boiler and pump. As you know from the introductory video, we have got 8 outputs on the controller that can turn things off and on. They're 12 volt outputs, so you can pop that into a 12 volt to 240 volt relay and apply 240 volt to fire up the pump and the boiler. Whenever any of these thermostats need heat, we turn the boiler and pump on. When all of the thermostats are happy that they're at the right temperature, we can turn the pump and the boiler off. There may also be a zone valve, which again you apply 240 volt to open the water to that manifold. So you may need to include that in there as well, that for that particular zone manifold you need to put 240 volt on there again from one of the outputs. So let's say you had 2 manifolds and a boiler, then you might actually use 3 of the outputs, one for the boiler and one for each zone valve. So you can open the appropriate zone valve to let the water flow in the right places. So not rocket science, pretty straightforward. Make sure you understand the plumbing layouts and number of manifolds, number of zones, number of zone valves, that kind of stuff, and then you'll know what you're doing. Going to talk now about simple, perhaps more traditional heating with radiators. So if the house has basically just got a boiler and say 8 radiators, then again you can use the RC1000 to control this and measure the temperature. I mean, typically in that scenario you might mount the RC1000 in the hall or the landing, and it's got its own built-in temperature sensor, and you don't need the remote temperature sensor. You can just have the RC1000 on the wall, and it's measuring the temperature, and the relay can be used to turn the boiler off and on. However, if you do want to hide the RC1000 in a cupboard somewhere, then absolutely no problem using the remote temperature sensor. And indeed, you could actually have up to 4 remote temperature sensors wired back to one RC1000, and what it'll do is it'll take an average across all 4 of them. Let us know if that's what you want to do, and we can tell you how to wire that. It basically involves wiring 2 in parallel, and then each leg has 2 sensors, so you can get 4 of them dotted around the house, which is quite a nice little feature. So if you do want invisible temperature sensors, and you use this, and if you're not worried, then just put the RC1000 on the wall in the landing or the hallway. And again, control from touchscreen or smartphones, and again, if you are hiding the RC1000, then you can use the remote temperature display faceplate to be able to see what the temperature is if you require that. So this is kind of a wiring diagram showing how you do this. Most typical installation of a radiator-based heating system has one of these things here, which is called a three-way valve. Makes our life quite a lot easier actually, because there's you simply on one of the cores of this cable, you put 240 volt on it, the valve opens, and then the way it's normally wired by the electrician is there's an end switch which then livens up the pump and the boiler for us. So we actually haven't got to worry about the pump and the boiler. That happens automatically as a result of conventional wiring. If you speak to the electrician, he'll know exactly what you're talking about. Most electricians have wired in sort of central heating systems, so you just need to put a relay between the 24 volt AC output on the RC1000 and the 240 volt, so to be able to switch a 240 volt through to the three-way valve, and once that's been livened up, your boiler and pump fires up, and then hot water flows through the radiator. Of course, when the current temperature reaches the heat set point, then of course the relay switches off and the valve closes and the boiler and pump shut down. So that's pretty straightforward. And again, as I mentioned earlier, you may have a property where you've got a combination of both, where you may have radiators in one area and underfloor heating in another area, and that's absolutely not a problem. Just combine the two together. The RC1000 itself, just from a sort of physical installation point of view, snaps open into 2 bits, where you have a back plate here that sort of the wiring center, as it were, that you mount on the wall, and then the front bit will then snap over the top of it. And there are 2 connection blocks on the back plate, one on the left and one on the right. The right-hand connection block is used for connecting back to the main controller. Mentioned in the introductory video that all the thermostats, up to 64 of them on an Omni Pro 2, you lose 1 zone and 1 output from the on the controller. So it's three conductors that's basically provide all the telemetry from the thermostats, so back to the controller, so you can go from the controller to the first thermostat and then daisy chain each one, and each thermostat has a unique ID that you set from the menu. So if you've got multiple thermostats, make sure you set the IDs accordingly. The left hand screw down terminal block on the RC1000 back plate requires 24 volt AC power on pins 1 and 3. That powers the thermostat, and then you've got pin 6, 7 and 8, and really we only mainly tend to use pin 6. Basically pin 6 goes live when the thermostat needs heat. and it's basically switching a 24 volt AC through to pin 6. So pin 6 can go to your relay to provide 240 volt to the three-way valve in the radiator example, or pin 6 can go to the actuator to liven up the actuator on the manifold, again when the thermostat needs heat. Obviously it's 2-wire, it's pin 6 and the common to obviously make an AC circuit. Recommend obviously that the main controller has a 24 volt AC power supply, so it's the same power supply. Recommend a separate power supply from the controller. Give the controller its own power supply, and then an RC 1000 have a separate 24 volt AC power supply for that. They're quite chunky power supplies, so no problem running sort of 5 or 6 thermostats off of one of those power supplies. They really don't draw very much current at all. Okay, now let's going to move on to retrofit solutions, which I find quite exciting. This obviously gives you opportunity to provide, app-based and intelligent heating control in existing properties without having to rewire or replumb them. This thermostat here can really just be a complete one-for-one replacement of your traditional thermostat. Normally in most properties there's a little thermostat of some form on the wall, and that's got a little 240 volt switch in it, which switches a live feed to that three-way valve we were talking about earlier. You can pull that off the wall and replace it with this thermostat. This has also got a 240 volt relay in it. Mount it on the wall, wire the switch live into the back of it, and you can set the heat set point, and obviously when the current temperature falls below the heat set point, then that relay becomes live, switches 240 volt to the three-way valve, and your boiler and pump fires up and heats up the house. When it gets to temperature, relay goes off, pump and boiler goes off. Very, very simple. The nice thing about it, of course, is it has Zigbee wireless. Now, Zigbee is a very robust wireless technology, which allows it to communicate back to the Omni controller. So now it will show up as a thermostat on the smartphone app or the touchscreen. So you can then control your thermostat from anywhere in the world from your smartphone, or indeed start putting rules in there about, set the temperature back when I arm the alarm and things like that. So you can start to get clever with the way you manage the heating within the property. It does require a couple of batteries in it, but the batteries will last sort of 3 years, so not a problem there, and they're easy to replace. And I mentioned Zigbee is a very robust technology. It was developed by the utility companies for really making smart meters talk to each other in large buildings. It's a mesh network infrastructure that dynamically reconfigures. So each powered Zigbee node acts as a repeater for other Zigbee nodes. So the more Zigbee powered devices you put in the system, then the larger the range you have. So it's not Wi-Fi, it's separate from that, so it won't interfere with any of your IP networking. It's a standalone wireless infrastructure. It's a global standard, and it's the same frequency throughout the whole world, and it's quite a well-respected technology. As opposed to, it's competing with Z-Wave. Z-Wave is its competing technology for wireless. The downside with Z-Wave is it is different frequencies in different parts of the world, so you have to be a bit careful which products you're using on the Z-Wave side. But Zigbee is the same frequency globally, so that's the preferred wireless mechanism that we like to recommend. Okay, just looking at sort of wiring, then here you can see as our three-way valve again with the boiler and pump, and again, as I mentioned, all we're doing is we're applying the 240 volt we need to the three-way valve. 240 volt on, pump and boiler fires, radiators heat up, and we use wireless to talk back to the Omni to give you control of that thermostat from smartphone or touchscreen, and from a programming point of view. Great little retrofit solution, easy to put in anyone's house, and every home should have one. Now, if you want to get a bit more efficient and improve the sort of flexibility of the system, then you really want to zone the system up. Because obviously the previous example is treating the whole house as one zone. Your heating's on or it's off. And it doesn't give you room by room control. This retrofit solution does. This uses a Zigbee wireless radiator valve, or also known as a TRV, a thermostatic radiator valve. Basically, you can fit these to the radiators. You may have seen TRVs before, where you have a little white knob on the end of the radiator that's labelled 1 to 6. And they're not particularly useful or user-friendly. They tend to be fairly binary, to be honest. Sort of 2 and below is off, and 2 and a bit and above is kind of on, and there's no real individual control there. Well, you can actually just unscrew those and screw this radiator valve on. Doesn't require you to drain the water down. Again, it's outside the water containment of the radiators. You unscrew it and then screw this guy on. Again, it contains a couple of batteries, which again last about 3 years. And the device will connect via Zigbee back to the Omni controller and show up as a thermostat. It'll give you a current temperature reading for that room, and of course a heat set point. And if you set the heat set point, or if the current temperature is below the heat set point, the little valve opens and allows water to flow into the radiator. And of course, when the temperature reaches the heat set point, then the valve closes. It's very intelligent. You know, if it's just ever so slightly below, if the current temperature is ever so slightly below the heat set point, it only opens a little bit. Whereas if it's quite a lot below, then it'll open fully. So it does actually modulate the amount of water flowing. So it's pretty clever. It also will exercise the valve. So in summer months when it's not being used, every now and then it will just open the valve and close it just to exercise it, to prevent it from jamming or causing any problems of that nature. So this is a brilliant retrofit solution. You know, you can walk into somebody's house and zone up their heating within a property without having to run a single cable or change any of the plumbing, which is just absolutely fantastic. So yeah, great solution. Provides room by room heating, and obviously the benefits of that are obvious. You know, if you've got guest rooms you're not using, you can set the temperature to say 16 or something nice and low, so that you're not wasting your heating energy to heat rooms you're not using. Because obviously with radiators that aren't being used, the water bypasses them. So the hot water coming from the boiler is really getting maximum efficiency of using that in the rooms that you do want to heat. So you're saving energy. You're also improving your comfort levels as well. Typically radiators downstairs are obviously radiate upstairs, and if you haven't got room by room control like this, then you tend to find you've got the radiators downstairs cranked up high to warm up downstairs, and when you go to bed it's really hot because all the heat's been rising, cooking the room upstairs. Whereas this is naturally going to level out the system for you. And it's a really nice capability. And if you have guests come around, then you can just ask them, what temperature would you like your room to be, and pull out your phone and set the temperature accordingly for whatever they'd like it to be. So brilliant solution. Big fan of this. Obviously you need a TRV for each radiator. So 8 or 10 radiators in the property, you fit a TRV on each one. And it uses Zigbee to talk back to the controller. And now, of course, we do need to still could turn the boiler off and on as required. So again, we use an outputs into a 12-volt relay to control the pump and boiler. And then if any of the TRV's current temperature is below the heat set point, we turn the boiler and pump on. And of course that water will only go through the radiators where the TRV is open, so it's only going to be sending the hot water to those locations that need it. And of course when all the TRVs have reached the heat set point required, then they will close, and you can obviously turn the boiler and pump off. No need to run the boiler. great device. They run very silently, so no problem putting them in bedrooms. They don't make a whining noise or anything. You almost have to put your ear hard up against them to hear the little motor opening the valve and closing it. Yeah, brilliant solution. You can probably tell I really like this solution. It's great, and definitely would recommend using this in as many situations as you can. Certainly, I mean, even if you just sell an Omni as an intruder alarm, there's a great upsell there. You know, you can speak to the customer. Do you want zonal heating control, also controlled from the same smartphone app that your alarm system is controlled from? You know, who wouldn't want that capability? With still in the retrofit space, you might find it difficult to get a cable from where the Omni is to where the boiler is. If that's the case, not a problem. We've also got a Zigbee wireless 240 volt relay. This will allow you to apply the 240 volts to the boiler where it needs to be to turn the boiler on without having to run cables to it. We have two versions of this, a 5 amp and 30 amp version. Obviously just a boiler isn't going to draw much current, it's just a switch, so the 5 amp version will be fine for that. And basically it sits on the Zigbee network. This is a powered Zigbee device, so this will act as a repeater as well. But other applications, outside lighting, pool pumps, pool heaters, commercial lighting, commercial heaters, you know, anything where you need to switch 240 volt and you can't get a cable to it is where you can use the Zigbee relay. So very useful piece of kit for any of those applications. I mentioned that powered Zigbee devices are repeaters. So our wireless battery-powered thermostat and our wireless battery-powered TRVs are not repeaters. That would drain the battery too much. They're known as endpoints. If you have a large property and you need to boost the range, then this little chap is very useful. It is a Zigbee repeater. So wherever you've got a power socket, you can plug one of these in and it will repeat the Zigbee signal, giving you larger range. So if you've got a TRV that's just too far away from the main controller, pop one of these in a power socket somewhere between the two and it will repeat the signal. And what will happen is multiple TRVs will find the repeater and then hang off of the repeater, which makes the network more efficient and more robust. And it's also a 13 amp relay as well. So anything you want to switch off and on with this can be controlled from the Omni, such as, for example, lights, lamps. Certainly, if you know, so I know certain people use them to isolate things like tumble dryers and washing machines that do get quite hot and have been known to start fires. So by putting one of those on the tumble dryer, when you arm the alarm at night in night mode, you can kill the power to the tumble dryer so that it can't possibly burst into flames. Or coffee maker, toaster, anything you like can hang off one of these guys and be controlled from the control system. But most useful is using it as a repeater. If you want to use Zigbee with the Omni, you do need one of these. This is the Zigbee interface module, or also known as the ZIM. Basically, it Zigbee enables an Omni. It's the transceiver, transmitter and receiver. It connects, it uses up one of the serial ports on the Omni with the RS485 jumper set to RS485. They use an RS485 protocol for range, so it can be a long. You can locate it wherever you like, get it nice and central in the house. Over a Cat5, you can go quite happily up to 100 meters because RS485 goes quite a long way. So you need one of those plugged into a serial port. Set the serial port to ZIM. And then you've basically Zigbee enabled your Omni for any of those Zigbee devices you want to enroll into the system. I mentioned air conditioning earlier on. We absolutely have the ability to integrate air conditioning systems as well, very easily using the Coolmaster. The Coolmaster device basically plugs into one of the serial ports on the Omni, and basically allows any air conditioning unit to show up as a thermostat. So again, it gives you a current temperature, and a heat set point or a cool set point. Most air conditioning units nowadays can heat and cool, so you can control them easily and seamlessly from the Omni. The Coolmaster basically sits on the there's a 2-wire bus that runs between air conditioning units, and wires into the Coolmaster, and the Coolmaster connects via a serial cable to the Omni controller. And then you can enroll each device into the system as a thermostat and control it as easily as that. So you literally just need this one piece of hardware, and it covers pretty well every make of air conditioning systems that are out there. So really easy to integrate. Additionally, we have some other items I thought I'd just mention, so you get a full view of everything. We do have a temperature sensor. This can either go indoors or outdoors. It's quite nice to actually fit one of these outdoors. Stick it under the soffit, so it's not in direct rain. But it's the printed circuit board is coated, so it's not going to go rusty or go green or anything. And that can give you the ability to measure the outside temperature, which is quite nice to show that on the touchscreens. The customer can see the outside temperature, and indeed you may make some automation decisions based on the outside temperature. So not a bad idea to throw one of those into a project. But as always, there's always more than one way to do something. I have known installers fit the temperature sensor in each room for temperature measurements in each room. It's a lower cost device than the OmniStat, which is the RC1000 we talked about earlier. No reason why you can't use this if budget is a real concern. Obviously you can't make it invisible, and there's no display on it, but it does give you a current temperature, and you can set a heat set point, and then you could use outputs on the controller to open and close and the manifold heads. There's no one solution fits all, so you could have a combination of things. I have known installers use this quite successfully for a budget heating control solution, because they're relatively inexpensive. We've also got another version which also does humidity. So if humidity is something that needs to be managed in a greenhouse, or in a library, or somewhere in an environment where humidity is important to monitor, you may use this device and then turn off and on humidifiers and dehumidifiers if necessary. We've also got a water temperature sensor here as well, which also can be used to measure the temperature, typically of pools or hot tubs. You have this little probe. Most plumbing in a pool situation or a hot tub has got that sort of white plumbing infrastructure. There's normally an access point where you can drill a little hole, put the probe in, silica it up, and then the probe is immersed in the water, and it will give you a temperature reading. This is only good up to about 50 degrees centigrade. It's meant for pools and hot tubs. It's not meant for measuring the hot water temperature in your hot water tank, which obviously goes beyond 50. It gets to 50 and then maxes out. All of these sensors cable back to a zone input on the main controller, so you will use up a zone input for any of these devices individually. Okay, we're going to have a quick look at PC Access now and what's involved in programming the system for your temperature and energy management. So if we're looking at the Setup tab over here, if I click on Thermostats, really all I have to do is name my thermostats. So here you can see I've got 6 thermostats in the project: kitchen, dining, lounge, study, hall and upstairs, and all I've done is I've clicked on here and typed in its name. That's all I've had to do. to tell it basically as a thermostat. The system basically, when it sees a thermostat with the default name, it assumes it's not being used. So by changing the name is how you tell the system there is a real thermostat there. Voices, I can give the thermostat a voice as sort of demonstrated before just by doing that. This is really a bit of legacy, to be honest, where people use the telephone dial-up facility to control the system. This is where you may say, press 3 for thermostats, and then it reads out, press 1 for the kitchen thermostat, press 2 for the dining room thermostat. But no one really tends to use that voice dialing capability anymore because we have the smartphone app. But just in case you need to use that. Importantly, you do need to look at the type. So I've got mine set up as auto heat cool. However, if it's a thermostat that's only for underfloor heating, there really isn't any cooling involved, I might set that as heat only. What that will do is on the touchscreen, the user interfaces, you can only set a heat set point and not a cool set point on that particular zone. So if there's no cooling available in that property for that zone, set it to heat only. And then you get rid of unnecessary buttons on the user interface that may confuse the user. Now, as I add my thermostats, it'll automatically start assigning these addresses, and these are the addresses you need to set on the physical RC1000 in order to make them line up accordingly. So make sure you put these addresses in to the thermostat. You press the big button, go into the menu, into the settings menu, and the first item is thermostat address, and you set that to line up with these guys, and then you're good to go. If you are using any of the Zigbee thermostats, then you would actually click on this and you would change it from an OmniStat to something else, such as Zigbee. You do need to be connected to the controller to do this, and the controller must have a ZIM connected. But if, assuming those things are true, then you've got the option to hit the enroll button. You put the thermostat in enrollment mode, or the device, be it the thermostat or the TRV. You put it in enrollment mode, and then this will start searching for it. For a device that's in enrollment mode, it will find it and populate its Zigbee address, and it will say enrolled successfully, and then you can hit OK, and then you'll have enrolled that into the system. So that's pretty straightforward as well. You just do one at a time, repeat it for each of the devices. If you're using the Cool Master, then for an air conditioning system, then you'd set it to Cool Master. When a Cool Master is set up, you have an adapter ID, a system ID, and a unit ID, and that's all set up by the air conditioning company that fit the aircon units. So you will need that information to be able to accurately address each of the aircon heads via the Cool Master. If you are using Zigbee or the Cool Master, I'm just going to pop over to the serial ports. Don't forget, if you're using Zigbee and you've used a ZIM, you need to make sure you've set the ZIM to a serial port where the function is set to Zigbee. And if you're using Cool Master on that serial port, then you need to make sure you set the function to Cool Master on the appropriate serial port. And obviously, of course, you can have Zigbee and Cool Master, of course, using multiple serial ports. Okay, we're going to look at a quick bit of programming now, because one of the things I said earlier was that when you're doing your heating control, you need to manage the boiler. And if any of the thermostats need heat, you've got to turn the boiler on. So how do you do that? I'm just going to jump into automation programming and add some programming to show you how that's done. Always start with all programming, we start with triggers. Now with this one, I'm going to use a cheeky little trigger, which is very handy, called every. We basically have the ability to do something every period of time. So I'm just going to say every minute. And what I'm going to say is every minute, check my thermostats, see if any of them need heat. If so, turn the boiler on. That's what we're going to do. So the trigger is every minute. My condition I can go to temperature, select the first thermostat, which is the dining room, and if the current temperature is less than, now here I've got specific properties, and temperature device property is what I want, and it's the dining room thermostat we're doing here. So if the dining room thermostat current temperature is less than the heat set point, let's say by 1 degree. So if the dining room thermostat current temperature is less than the dining room heat set point, then we want the boiler on, right? But I want to do that for each of my thermostats, and it's an OR. So I've clicked the OR button to put an OR statement in here, and now I can do the next one. So temperature, hall, current temperature is less than the hall heat set point by 1 degree. And if the temperature for the kitchen current temperature is less than the kitchen heat set point by 1 degree, well, obviously you can choose what you want to do there. And I forgot to put my OR statement in here, so I'll just pop that in afterwards. And there's my OR statement again. I'll just do one more for the purposes of this exercise. Temperature, so we've done the dining room, done the hall, done the kitchen, we'll just do the lounge. Current temperature is less than the lounge heat set point by 1 degree. The action is going to be to turn the boiler on. I've got the boiler under an output. So I've got one of my outputs through a 240 volt relay, and there it is. There's my boiler. I'm going to turn the boiler on. So every minute, if the dining room, hall, kitchen or lounge current temperatures is less than their associated heat set points, then turn the boiler on. And obviously I can customize those heat set points per zone, giving me total zonal control of the property. That's great, that turns the boiler on. Now I want to turn the boiler off conditions as well. So I'm going to copy that, select down here and go paste, make my life a bit easier. And this one, now, to turn the boiler off, all of the thermostats must be at the right temperature. It's not an OR statement anymore, it's an AND statement. So I want to get rid of all of my ORs because every thermostat must be at the temperature it needs. So if I go to the dining room, current temperature is greater than the dining room heat set point. And now I'm in the hall, current temperature is greater than the hall set point. And kitchen, current temperature is greater than the kitchen heat set point. And the current temperature is greater than the lounge. Okay, so now we're saying if the dining room, hall, kitchen and lounge current temperatures is greater than the desired heat set point, then don't turn the boiler on. Now we're going to turn the boiler off. There we go. So with those two bits of logic, I'm now able to control the boiler based on what my thermostats require. So hope you followed that. If you want to rewind and watch that again, feel free to do so. But it's pretty straightforward. Of course, I would need to connect to the controller and then write that programming down to the controller for that to then take effect. Do make sure you test the system properly to ensure that it's all working correctly. Certainly, with each, especially if you're doing zonal control, go to each zone, set all the set points down low on all the zones bar 1, and then crank that set point up above the current temperature. See that particular manifold actuator open or the TRV open. Make sure it's working correctly and that zone heats up, and then you can turn that one down and turn the next one up and check them all individually and make sure they're all working correctly. That, you know, that there are mechanical items in here with the actuators and the TRVs operating the valve on the radiator, so you do need to make sure all those things are operating correctly, and indeed that the boiler is coming off and on correctly. Of course, you can monitor the boiler status by looking at the boiler output from the smartphone app or from the status tab of PC Access, and you can see it's doing what it should be doing. Okay, well, that pretty well concludes this module. I hope you found that useful. If you have any questions, feel free to contact us either by phone or email. Have a look at our website, and you can follow us on the various social media for updates and new product alerts. And I look forward to speaking to you again on the next training video. Thank you very much.